Okay, good morning, students. So, I hope you are doing fine for your assignment. So, if you have any question, please let me know. But today we will be talking about the model view model. It's a design pattern which is available for the mobile development. Even model view model has been also been used in other software development environment like desktop development, um, iPhone development, and Android development. So we call it an MVVM model, view and view model. So these are the abbreviations. That's MVVM. What it will do, it will help us to separate different parts of our application. So we have user interface where the user can interact. That's the one layer, we call it as user interface. Okay, so the users can see what with different components, different buttons, different input fields, different images, that different reports, even graphs we can present over there. So these are the things that the user interface with which the user can interact and do some useful stuff within your application. And behind that user interface we have the application logic, or we call it a business logic, the processes which are running in the background, getting the data from the database, getting the data from the internet, and doing all those calculations and showing the results to the user. So this specific model, that is the MVVM, it will help us to separate that different parts of the different components. The basic business logic is separate part, a separate layer, and the user interface, which is more activity and fragments. We have only talked about the activities. Okay, so inside the activity, we don't want to implement everything that till now we have been doing. In the last lecture when we discussed how we can connect with the cloud database, I use a separate demo data model class in which I implement the things to connection of the connecting connection between your application and the cloud database. It has been implemented in a separate class, so it was just of one way to do the things. Here we will talk in a more detail that how we can separate different parts of the application from each other, and uh, we can concentrate on one part in one app on user interface in the activity class, and in the business logic, which are the separate, we call it a model. Okay, so in that particular model we can only concentrate on the business logic, how we can implement the processes, how we can serve the things, how we can do the calculations, and all that kind of stuff. So MVVM help us to drive your user interface. User interface is driven by the business model or the business logic. Do not lose data if the Android OS destroys your app to free of up resources. What does it mean? It means that you know that the activity has a complete life cycle: on create, on start, on pause, on restart, on stop, and then we also have on destroy. We as a application owner, we don't have the control on that particular specific, or what you can say, that the life cycle of the activity. The reason is that the life cycle, the activity is something which is visible to the user, and that is owned by the Android operating system. Okay, if the user is using it, okay, it's fine, because it is visible to user is interacting with them. Android operating system is not going to destroy that particular specific application or specific activity or the class object. On the other hand, if that particular specific activity is not visible to the user, what happens? If the Android system, again, it's something which is like depend on the operating system, depend on the resources which the operating system has at that time, how much memory is left. Based on that, the operating system will decide that which activities, user interface part, of an application or maybe multiple applications which has not been used by the user for quite some time, it will automatically, without any warning, it will delete that particular specific user interface part, that is the activity object. So if we have implemented everything, all our business logic and everything inside that particular specific activity class, then what will happen when it is destroyed, when it is removed from the deleted from the memory, all our resources, all our data is gone, unless and until we have implemented some lifecycle methods, on destroy method or on stop method. We are saving that particular specific data maybe in the database or something like that. But we don't want to do that kind of like overloading one activity, one user interface object with all of our business logic. Okay, so we are separating that particular user interface part and the business logic, which is actually the backbone of your application, which is providing all the services. So we are separating these two parts. Okay, and if it is separate, if we have implemented in a separate class, if the activity class is destroyed, your business logic still exists in the memory, and that is something which is owned by your application, and the operating system is not going to remove that thing on its own. So that MVVM will help us to work on that. Continues to work in the case of no network again. If it is, we have something like this, if we have implemented the MVVM, even your network is not available. If your application depend on the network to provide the services, still without the network, your application can work. So I will show you shortly that how it can be done. So this is our architecture. On the top, that is the activity, that is the user interface. On below that we have the view model. View model is again, it's a part of the MVVM architecture. Activity, we know very well that what is an activity class, what we can do with it. View model we will discuss today, and it is also a specific, what you can say, API. And in addition to that particular view model, we will also talk about the live data. Live data is something, if something had changed in the SQLite database, it will automatically reflect those things inside our user interface. So that is a live data, that is a concept that we are going to work on that. And then below that particular view model, we have a repository. Again, repository is simple class, it's a POJO, it's a simple class. And then we have the model that is actually communicating with your room database or the SQLite database using the room framework. And then we also have another part. For example, here they are mentioning the retrofit, but we will be talking about that how we have a remote database controller which can help us to connect with the Firebase. Okay, so let me show you our application scenario. So this is our application scenario. We have the main activity. In the last class, in the last lecture, we have seen that we have the main activity in which we are showing some records of the students from our Firebase real-time database. Okay, so this is our user interface, this is our view model, and then we have the repository which is responsible for controlling different models. We have a remote database handler, it's a remote database model which we are connecting with our remote Firebase real-time database and getting the data from it, or we are updating the data inside it. And see, other part is the local database handler, which is going to help us to connect with the local um, SQLite database using the room framework. So we have already implemented that part, main activity. I will show you step by step. Okay, and then we will start implementing different parts. Maybe we can start with the remote database, then we implement the local database, then we implement the repository, then we implement the view model, and then we connect that view model with our main activity. So let me start with our main activity. So this is our main activity in which we have the title, this is a text view, we have a button to add a new student ID, and then we have a recycler view over there. So you can see that particular specific code, that XML file, uh, which is representing that particular layout. It is here. Okay, so because we are talking about we need to show some data, so we also need to create a data model, and that data model is exactly the same that we have seen in our last lecture. That's a student class in which we have the student ID, we have the first name, last name, gender, username, password, and mobile. So we create data model package and create the student class if you want to start with that. I have already created a starting activity, starting project, which I will put it on the Moodle and you can download. And during the class, we will be working on that and adding other functionality inside it. And that is your SDLT05 as well. So all the things that we are going to learn in this lecture that you need to implement by yourself inside that particular SDLT during the class hours, or maybe afterwards if it is not finished in the class. So I will be there to help you if you have some concerns, if you have some questions, I will be there to answer those questions. So we have that particular specific model, that is a student class. Okay, and because let's start with the room database, local database implementation, in which we are going to create our local database handler. So of course, if we want to reuse the room, we need to add those dependencies in our Gradle file, that is the app Gradle file. Okay, so we need to add that, and you know very well where we can do that. If you are not sure, I will show you quickly where we can do that. Where is my yep, here it is. So you can see that if you want to change, let me first change it to the Android view, and here it is our Gradle file. Okay, inside that particular Gradle file, I am talking about this particular, we have two Gradle files, one is the project and one is the app level. So I am talking about at the app level, and in this particular dependencies inside this particular specific, what you can say that this part here somewhere within that particular dependency part, you need to put those lines which I have just shown you here. Okay, so you need to put these lines inside that particular dependency curly brackets block. So once we have added that, it will ask you to synchronize. You need to synchronize that particular specific project uh, uh, Gradle file, and automatically it will add all those dependencies within your project. So what we need to do next is we have that particular specific model, the student model, the student class. We need to convert it into an entity. So convert our student class into an entity, and we have already discussed all this. We have the student SID will become the primary key of that particular column. That particular table, we are saying the aggregate of entity, and then the table name will be the students, that is the name of the table within our database. We also introduce our different column information and so on. So we need to convert that student class into an entity. Okay, so we have already discussed about that when we start learning about the local database and the room framework. We have already discussed that. You have already completed the self-directed learning task, that's SDLT04. So you have already know all those things. So what we need to do, we have a student class, we need to convert it into an entity by annotating with the different type of annotations for its at the class level, that is the entity, and the fields level, which are the primary key and the column information and so on. The next step in implementing the room architecture or the room framework is the adding a DAO, data access objects. So here we have that particular specific data access object, which is helping us to read the data from the database, SQLite database. It will help us to insert a student. It will also help us to delete a student. It will help us to delete all students, and it can also help us. So we have this particular specific. So what you need to do in your data model package, you need to add that particular specific interface, and you need to write that particular specific information in the query, add the insert, add the delete, add the rate of query, and then add the rate of insert. So we have, again, it is inserting the students as a list of the students, multiple students you want to insert. So this is a DAO and data access object that we need to create. And one thing, this is normally what we do, list students. Okay, so whenever we are reading students from records from the students table, it will return us a list of the students. So we need to change that particular behavior, or need to change that particular return type to incorporate our live data. So what we need to do here, we replace that particular part with this thing. And once we replace this particular part with this thing, our DAO will become like this. So instead of having only the list of the students, it is a list live data on that particular specific list of students, and that will help us to observe any changes inside that particular data. If some change happen in that particular data, it will automatically retrieved from the databases and show it in our user interface. We don't need to like do it ourselves. Fine. So this is the concept of the live data. What we are saying here, that we have connected our user interface with our database using the live data, and if there is another process which is inserting the data inside the database, the new data may come in the database, or maybe the existing record has been updated by some other processes or some other application, then the live data automatically looking at all the changes in the database, and if there is something which is changed in the database, it will automatically retrieve those information and serve it in the user interface. We don't need to do it by ourselves. We don't need to look into that, or we do not mean to keep on looking that if there is a change in the database, we need to update in our user interface. So this is the purpose of the live data. So here we have changed that particular read all students return type using the live data. Okay, and then of course the last part of the not the last part, second last, you can say that. So this is our room database. We need to create an abstract class of the room database, and you know that in that particular specific class, it is an abstract class which extends, which is the child class of our room database. We also have an abstract student DAO. That is a method which is going to return us the student DAO object that we have just created. This one, this student DAO object, it is going to return us. It's an abstract method which need to be implemented, and that is implemented by the room data access framework. So we don't need to implement. So that's why this particular specific method is abstract. We also introduce that particular specific field inside this database class, that is the static long student ID, STID, is equal to 0. Actually we want to, because we have two parts, one is the Firebase and the other one is the local database. Data is actually in the Firebase, which has been replicated in our local databases. Okay, so we have a student ID over there is 1 2 3 4 5 6, and in that I will show you that there is a what you can say that we have that particular specific ID over there, which we are keep on updating whenever we are adding a new student record. With we add that particular ID from the Firebase, and then we increase it by 1, and then it will automatically update it, not automatically, we update it in the Firebase database, and next time when we want to add the new student record, we will use that new ID to put it into our student record. So that's why I put it here, to keep it in our local um class, so that whenever we want to add a new student, we will use it. And then we also have the private static student database instance, that is again a database itself instance. And then whenever we are creating this particular specific object of this class, we are going to create, if it is a what you can say singleton object mechanism, only one time this particular specific student database has been created, not all the time. We will not create multiple, only one instance of that particular specific database is created, and if it is null, it is created. If it is not null, we will just return that particular specific instance. So that is get database. from that particular student database class. Okay, and the next thing is we are creating that handler, which is the main class which is going to communicate with our room SQLite database using the room of framework. So this is our room database handler class. So room database handler class, it has what multiple parts. So I will break it down. I will explain each and every steps here. So first part is the data part. If you look at that, we have these private variables. We have the list and the list of the students and the repository. List of the students. Uh, I think this class, this picture you don't don't keep it like that. It is the step by step. So we have created that particular database handler or local database handler or room database handler class, and in that particular class we have these three data parts, three fields. One is the student DAO, data access object. The other one is a live list student, which representing all the students which are present in our database, in our local database, or in our, eventually it's actually coming from, data is coming from our Firebase. And then we also have a repository. A repository is a class which we are going to create in the later part of our lecture. So that is a class, simple Java class which we have created, and we are creating an object of this one. And then we also have what you can say that we have the constructor in that particular database room database handler class. Room database handler, that is the name of the class. So we have exactly the same name of the method, that is the constructor of the class, which is taking two parameters as an input. One is the context of the application and the other one is the repository repo. Okay, so we are taking these two parameters. The second parameter, that is repository, we are assigning it to our repository object, that is this one. Okay, and the second one, we are saying that we are going to initialize our data access object using our student database class that we have just created. So student database class, we are, what you can say that we are, let me show you this one. So we are, what you can say, this is a static method. We are calling this particular method to get the instance of this particular specific student database object. So once we have created that particular, we need to provide the context of that particular specific application. So we are passing the first parameter as a parameter to this get database method. And once we have that particular, actually this particular part, student database dot get database context, it will give me back the student database object. And in that object we have a student DAO method which is going to return us the student data access object, and that is we are assigning it to our this local variable, this class level variable student DAO. So we are initializing our student DAO object, and using that particular student DAO object we are reading all the students from our database and putting that inside our all students variable, that is actually a live data list of the students. So we have initialized these three fields inside our database, inside our constructor. The next thing is we have that particular specific, we don't need to access that particular student DAO, we have, but we need to access that all students, because these are the students that we want to show in our user interface. Okay, so if we want to show it in our user interface, we must have a method to access that particular specific data from this room database handler class. So we have a getter method, so which is going to return us a live list of the students. We get all students, we will just say that return all students. So we will help us to retrieve the data from this room database handler and we can access it. So that is a getter method that we need to implement inside our room database handler class. Okay, so again let me go back. We have three data parts, three variables that we have declared in the class. Then we have our constructor, which is help us to initialize all these three variables. Then we have a getter method, which is going to help us to retrieve that student's data out of this particular room database handler, and we can show it in our user interface. And the next thing is we want to add, because this is a room database handler in which in our room database we have only one student table, so we need to provide a way to add a student in our database or remove a student from our database. So this is the add student method. So what it will do, it return me nothing. It's a name of the method is add student, and then we have it just take one student object as an input. And in this particular specific object we are saying the new add student, because we have created that particular async task class. That's a thread class which is going to add the that particular specific student object inside our database. So we are saying that add student async. We are providing the student DAO, which is also the local variable in this room database handler class, and then we are executing that particular specific thread and passing our student object as a parameter to this execution. And this is the definition of our async task class. So add student async, that is the name of the class. It is the child of the async task. The input is the student. Then we have the progress. We are not showing any progress, so we have void. We are not returning anything, that's why it is also a void. And then inside this particular specific thread class we have the final student DAO object, which is public, and then we have the constructor in which we are initializing that DAO from our student DAO with our student DAO object that is present in our room database handler. So we are assigning it, and then we have, you know, that this is the do in background method. This is the main method. When we say that dot execute, once we have created that particular specific object of this add student async class, when we say dot execute, actually it is going to add this particular, it will run that particular specific method do in background and pass this particular student parameter or the input here inside that particular students. So because we are passing only one student, so we are students 0, and then in that particular DAO we have the insert student method which take one student as an input, and it is going to be inserted inside the database. So this is our add student method as well as the add student thread class, which help us to add the student inside our database. The next thing is remove student. Again, the same thing that we have done for the add. The name of the method is a remove student. It takes the student object that we want to remove from the database. We have a we have defined this remove student async class, which is actually the subset or subclass or the child class of the async task. It take one input, that is student. It does not show any progress and it does not return anything. Again, inside that particular class we have a private variable data access object. We are initializing that particular data access object with the student DAO, which is present in the room database handler. So we have, when we create that remove that student async task class object, we are passing that student DAO, which has been eventually initialized inside this DAO object. And in that particular DAO, using that particular DAO object, we are deleting that student from our database. So exactly the same way, insert, now we are deleting. So we have insert method, we also have a delete method, and we can also add the list. We can also have that if we have multiple students that we want to add, we also have that one. So we are saying that add students, not student. Students is a plural. So we are providing a list of students. We are creating a add students async task class object, providing that as a parameter to the student DAO, and then we are executing and passing that particular student list into as a parameter. And this is our async task class for this particular purpose. add students async, that is a child of the async task. The input is the list of the students, no progress, no um, output or the return type. And then again we have DAO object which has been initialized with the student DAO. And then we have the overridden this particular do in background. Whenever we are dot execute, it will come here and it will insert that particular specific list of students inside our database. And in the previous examples, insert student or the delete remove student, we did not put it in the try catch, but here we are putting it in the try catch thing. So because normally whenever we are performing some database operations, it is possible that we have that SQLite exception. Okay, different type. This is a generic one. This is the parent class of all the SQLite exceptions. So if we are handling that one, we are actually covering all of them. So this is the implementation of our room database handler, which will help us. We have 3 variables inside that room database handler: student DAO, student data access object. We also have the student data object. We also have the repository object that we will be creating later. And then we also have a way or the public method which will help us to insert a student or add a student in the database. We also have a public method which will help us to remove a student from the database. We also have a public method which is helping us to add multiple students inside our database. So this is the complete implementation of our data access object, and that you need to implement by yourself, adding yourself during our class when we by using that starting project that we will be working on. So if we come back to our lab scenario, we have main activity, we have new model repository. So this particular part we have implemented completely, so it is done. Now we will talk about our remote database handler. So remote database handler, again, it has 2 parts, data parts, in which it means we have created a remote DB handler, remote database handler class, and in that particular class we have 2 private variables, 2 fields, data fields. What is the all students, again list of students, all students. And then we have the private repository. Repository is again a class that we are going to implement just after once finishing this particular specific remote database handler. But don't worry about it. I mean, once in the beginning when you put that particular private repository, it will give you an error message, so don't worry about it. Or you can just create an empty repository class over there before you started implementation. Okay, so these are the 2 data parts or data variables inside this DB remote database handler class. And it is a simple Java class, not the child of any API class or something like that. No, simple class. Again, remember that from the previous not from the previous, so let me what you can say that to remove this particular specific thing. So constructor, again data part is not from the constructor. So we have some I'm just making few changes inside my slides. Okay, don't worry about it. So actually data part is not coming from our previous lecture. We don't have the data part over there. Okay, we have the constructor in which we have 2 data parts, all students and repository, and here we are going to initialize them. So repository is coming from the repository class itself, and we are going to assign it to the repository. And then we have all students is equal to new array list. It means it is an empty list which we are initializing into that all students. And then we are saying that read records. Read record is actually a method which is present in this remote database handler class, which we are going to discuss a little later. Okay, I mean just after 2 slides. The next thing is we have a getter method which will help us to get those all students from this database handler, it is going to return that list of the students to us. And now we have that read record method that we have just mentioned in our constructor, that we have calling the read records method. So this is our read records method. This read record method, if we look at from the previous lecture, it is like that. So we have a Firebase database. We have Firebase database get instance. We have already connected our application as a client to our Firebase project in our Firebase account. So we have already done that particular part. So once we have done that, it will help us to get the instance of that particular database, and inside that particular specific, if I can show you quickly, let me come back to that particular specific, show you. So you can see that this is my Firebase account. We have created that particular real database. So once you are saying this particular part get instance, it is going to get me the instance of that particular fire FIR cloud database 89289, and in which we have this particular reference, and we also have this STID value is 8. And if you look at that, the last part is having the STID 7. So this is the STID which need to be added as a student ID inside our student object, which is D8. Okay, so let me go back. So we get the instance, the complete database, and then inside that database we have the key value pair, which is where the key is represented by D303 Firebase demo, and it is containing those 0, 1, 2, 3, 4, 5, 6, the student objects or the student informations as a key value pairs. And then we are on that particular specific key or the list of the students, we are adding a add value event listener. So value event listener, what it will do, if there is a change in that particular specific value of this particular key, it will be automatically executed this particular part inside our Android application. So it say that on data change, it is returning, it is giving as an input as a data snapshot. Data snapshot represents the value of this particular specific key, that is the D303 Firebase demo, the value itself. It means this data snapshot is actually representing this particular part, these 7 objects. It represents these 7 objects, and once we have that particular data snapshot representing all 7 objects, that student objects inside our remote database or the cloud database or the Firebase database. So we have that one, we have the list students is equal to new array list students. Actually this is the old implementation that we have done in the last class. And then we have a for each data part from inside the children of this snapshot, it will have 7 children, 0, 1, 2, 3, 4, 5, 6, and then we are converting that value into a student class object and adding that student object inside the student list, and then eventually we are updating that thing inside our recycling adapter and updating the data. So when we look at that particular specific thing, it will show me all those. Where is my cursor? So you can see that it is showing me all these 7 objects, 1, 2, 3, 4, 5, 6, and 7. So once we did that, it is going to be shown in that particular recycler view. Okay, so this thing we need to change. The reason is that we are not directly reading from the Firebase and showing it in our user interface. So what is this app scenario here? We are reading the data from the Firebase, adding that particular data inside our local SQLite database, and from SQLite database we are projecting or showing the data inside our user interface. So we need to change that particular read records method as follows. So modifications, what modifications we are doing? We are not creating, if we look at back, we have that particular, we are creating a local variable inside this particular specific method. Now if we go back, we have that particular specific list of the student, that is the class level variable. So we are using this particular variable to show the information. So we have that class level variable, we are saying that new array list of the students, and then again we are reading all those 7 objects from our database, Firebase database, and then converting each object into the student class object, and then what you can say that we are putting that we are converting that into student class object and adding that inside our all students data part. And once we have finished adding all the students inside all students data part, we are using the repository object to notify Firebase data changed. So we are notifying our repository that there is a change in the Firebase database, and what they need to do, it will add the new list of students inside the database, SQLite database, and then it will be automatically shown inside our, or updated inside our user interface. So the other thing that I have changed here, in case of on data change, in case of on cancelled, it means there is some error in reading the data from our database. So what Firebase database, so what error is going to be there, I'm just trying to put it over here. I'm just logging it so that if there is something, I can understand from where that particular error is coming up. Fine, so this is the change, and now as I shown you, this particular specific STID is actually representing 0, 1, 2, 3, 4, 5, 6. So this is actually on the older picture. Okay, this is the current form or the current scenario inside our Firebase database. So we have 8, we have 0, 1, 2, 3, 4, 5, 6. I have already provided a JSON file that you need to upload if you want to connect with your own what you can say that with your own Firebase account, with your own project in your Firebase account. You can upload that particular specific JSON file and it will automatically add these 7 objects, and the STID is equal to 0, so inside your project. So you can do that. I have provided that JSON file, so if you want, you can do it yourself. That okay. So and that is what you are going to use for our adding new students. That is the part which you need to implement. I will explain it here, but you need to implement by yourself. Fine. So this particular, I mean, reading this particular part is still missing here. I mean, we are only reading all the students part. Okay, and once we have all the student parts, we need to implement that particular part, and we also need to, what you can say that we need to add that thing here. So reading this particular part of the from the Firebase database going here, so we need to add more code here. And what is that code? It's very simple, so at least for me. So again, we are saying that we are trying to from our Firebase database, we are getting the reference of the child, that is the key of this particular part, that is STID. We are getting that particular child, and it will return me a database reference. And on that database reference, it means on this particular specific STID key, we are adding a add event listener. We are adding a add event listener. It means that whenever there is a change inside this particular specific part, it is going to be execute this particular method here, that is on data changed. And again, data snapshot is coming up. Data snapshot is actually representing the value of this particular specific STID key, that is 7, and it is going to be a long key. We are converting it into a long key. So we are saying data snapshot or get value, convert, we are putting the explicit type conversion into a long, and then we have long STID, And then remember that we have a student database. Inside that student database we have a static field, that is stid. So we are assigning this particular stid in that particular student database static field. Fine. And then we are putting that particular debug information inside our debugger. I can show you this thing here if I can. It's not here, but anyway, so it is going to be, if I can show you here, where is my, do we have other project open? No, other project is not open yet, which is the finished one, which I have already finished. So I have implemented all those things before giving you explaining you all those things. I have implemented, tested everything is working. Okay, so in that it is going to show that particular, in the log cat area, it is going to show me the last value of the student ID. Okay, so this is the part in which we are reading that particular specific data, and if there is a change in that particular data, it will automatically come and update that particular student ID inside our student database object. And so that is the other part which has been implemented. So this is the complete code for our what you can say that for our read record complete. So you can see that the first part is reading the student objects or student informations, and the second part is getting that particular specific student ID information from our student remote database and putting it into our student database object in the static field. Okay, so this is the complete code for our read record method. And we also have to write the information inside our Firebase database. So we also have the method for that. Again, it's coming from the previous lecture. The only thing that I have changed here, so this is same, we are getting the Firebase database instance, we are getting the reference for this particular D303 Firebase key value. We are pushing a new key inside it and get that key back, and using that particular specific key we get that child which has no value assigned to it, and we are setting the value of the student, and student is coming as an object to this particular specific method. And then this is the part where we not only add the student inside this particular key value pair, but we also need to update the stid inside our I'm talking about this particular specific stid value. So whenever, where's my cursor? Okay, where is my cursor? Yeah, here it is. So this particular specific value I also need to update. We are adding the student record. It will add a 7th record here with us, with the long key, and add that thing over it. But this thing has been updated, this thing has been increased. It means we need to make it 9. So we are also putting that particular specific ID inside it. So what is that? Set student ID, and this is the set student ID method. Set stid method, which take a long value as an input, which is coming from our student database.stid, and we are adding. So again we are getting the reference, and then we are add this particular specific value, we are changing its value with the new one. So if it is 8, it will become 9. If it is 9, it becomes 10. If it is 10, it becomes 11 automatically. That we have implemented. We need to implement inside, or we will be implementing inside our add student method. Remember, in the main activity we have add student method, or add a student button, in which we start a new activity, and in that activity we are going to get the information from user, and it will be added inside our Firebase database, and eventually it is also added automatically inside our local room database. Okay, so with this read and write operation, we have completed our remote database handler. Now we will talk about the repository. So we need to implement the repository. This is the situation right now for our Java code. We already have the main activity. We have a student recycler view adopter, student recycler view holder, which are already part of our starting object. You don't need to worry about it. It's already there. And we also have the student object. Now we have added these things. First of all, we added our we convert that particular student object into our entity. Then we created the student DAO. Then we created the student database object, and then we have created the room database handler, and now we also have added our room remote DB handler. So remote DB handler is also added. So now more or less our data model has been complete, because this is our data model, the business logic which we have implemented over there. And now we need to add our repository. So add a repository class. It's a plain simple object, plain old Java object. It's represent the business logic. You read all records from the Firebase database. This is our business logic. Read all the records from the Firebase database, add these records inside our local database, and serve the user interface from the local database always, and not from the remote database. For example, in this scenario, if our application, if our mobile is not connected with the internet, still we can serve the information to our what you can say that users. It can see different users, it can interact with our application, and so on. So that is our business logic that we want to implement in this application. So repository class, in the repository class we have these two handlers, remote database handler, a remote DB handler, and the room database handler. So we have these two handler objects which we are going to use here. And then we have the constructor here. This is our data part, this is our constructor, and that constructor, in this constructor actually we are initializing these two remote DB handler and the remote room database handler objects. We are initializing them. We have already seen their constructor, and remember that we have the repository that we are initializing in the room remote database as well as the room database. So this is, we are providing the object of this repository class as a parameter, and it will automatically what you can say that it is automatically initialized inside those that handlers class objects. The next thing is notify data change, notify Firebase database change. If we go back to our what you can say that read operation, so we have repository dot notify Firebase data change. So actually inside our repository we are calling this particular specific method once we have read all the records from our Firebase cloud database. So this is the method that we are calling over here. This is the method. In this particular method, what we are doing, we are saying that inside our remote room database handler we have a method which is adding a list of students inside our database, add students. So we are just calling that particular method. It means it is going to add all the students records inside that particular specific database, local database, which we have read from our room remote database or the Firebase database. We also have that particular getter method which will help us to get the students records from our room database handler, which is a live list of the students. Remember that. So let me show you back quickly in our room database. Where is that room database handler? We have that particular live list of the students, all students. So what we are doing here, we are getting those records inside our repository and passing above, whoever called that particular specific public method get all students. So from our room database handler we are getting all students and returning back to the calling entity or calling method. And then we also have a method which is going to add here. When we say add, we are not going to add that one inside our local database, we are going to add inside our remote database handler. And if we look at that, we have this particular specific method, add student. inside our remote DB handler. So it is going to add that record inside our Firebase database and update the student ID information inside as well. So simple. The repository is quite simple. We have an object of DB handler, remote DB handler, room database handler. We are initializing or creating those objects, two objects, handler objects. If there's a change in the Firebase data, we are going to notify this to our repository, and repository is going to add all those student records which we have read from our Firebase database inside our local database. And if someone want to get the information and know what someone is actually the user interface need the information about the student, it will ask the repository, and repository is going to retrieve it from our local database and give them back as a live list of the students. And then whenever we want to add a new student, it will be added inside our Firebase, and because inside the Firebase the data has changed, it will automatically come to our local database. So by adding in the Firebase database, actually we are changing the data inside our local room database, and when we are changing it, because of that live data property or live data facility, it is automatically changed inside our user interface. So it's a long chain. When you click on the add new button, new activity started, you get all the information from the user. It is when you click on the add student, it is added inside the Firebase. When there is a change in the Firebase, it is automatically come back to our application, and this new record has been added inside our local database, and then local database is showing up inside that RecyclerView. So it's a chain that is going on inside this particular specific application. So if we look at that, now we have implemented the local DB handler, we have implemented the remote DB handler, we also implemented the repository. And if we look at the till now, that local DB handler, that repository, and the remote DB handler, they are simple classes. They are not the child classes of anything. They are simple classes, and these classes are owned by our application. This is our business logic. We don't want to lose it in that life cycle methodology. So they are there always. Okay, so this is the one backbone, the business logic, this particular specific part, the business logic of your application. And then we have to implement the view model. And what is a view model? View model is again a class which is actually the child of a view model. It is coming from the Android X lifecycle.view model. And what is the purpose of this view model and the live data? They are, what you can say, that they are the life cycle aware methodologies, life cycle aware components of your Android API. What do you mean by life cycle aware? Life cycle aware means that they know that the activity is visible to the user or not visible to the user. That activity exists in the memory or it does not exist in the memory. They keep track of that particular specific activity with which they are associated, because this view model is associated with the what you can say, view model is associated with the main activity. If the main activity due to some reasons has been destroyed, has been deleted from the memory by the Android system, this view model knows about that, and then it is not going to keep on updating the data inside it, because it know that that particular specific main activity does not exist in the main memory. In the memory it is not longer there, so it will stop updating the information using that live data. So live data and the view model, they are the life cycle aware components of your application, which know that the activity or the fragment exists or not exist. Even it exists inside the memory, your activity, but because it is not visible to the user, it is not doing anything. then again the live data will stop updating the information inside the activity. Why? Because user is not looking at it, user is not interacting with it. When user is not seeing it, we don't need to update the information inside. Once user will go back to main activity again, then we need to update it. So this is again, it will know that it is still visible, not visible, still exist or don't exist. So accordingly it will change. And because it is in the background, it is there in the memory, it will not updating the information. It means it will increase the performance of your application intelligently using all those resources. Okay, so these are the life cycle aware components of our application. So we have created a live a view model class, student view model, and this is the child of the view model, that is the API class from our life cycle method, life cycle library. And then we have private repository. We are just creating the object of that particular specific repository class. And then we have the constructor of this class, in which we are passing the context, and we are passing that context to our repository class and initializing our repository. In the repository, it will actually create the remote DB handler class and the room database handler class. It will initialize those, and you passing those contexts to them as well. So and actually this context will help us to uh, observe the life cycle state of the activity. And then again we have a live data, we have get all students from the repository class, get all students. So actually this repository class is getting that particular live list of students from our room database handler. So actually it is coming from our room database handler through the repository, through the view model class. So we get all students, which is actually a live list of students, live data list of students. And then we also have add student. Add student mean it will, inside the repository we have add student, it will call that method. And what will happen, it will call the add student method of the remote DB handler, which is going to add that data student record inside our Firebase database and eventually come back into our room database. So by the implementation of the view model, we have completed this particular part. You can see that. Okay, and then we talk about the main activity. We have already seen the interface, we have already seen right in the beginning. So now we will need, what we need to do, we need to create a view model variable and initialize it. We also need to configure the main activity as an observer of the live data. It means that whenever there is a change inside the room database values or the information or the students table, it will automatically come back to the main activity and run a specific method to update the user interface. On callback event, set the data part of the RecyclerView adapter and notify the changes in the data. So I will quickly show you the data part. This is the class variables inside our main activity. We have the student RecyclerView adapter. We also have a RecyclerView, which we have added inside our user interface. And then we also have the object of the students view model. And this is our on create method in which we are initializing. This part you know very well, we are initializing, creating that particular layout file for the main activity. Then we are setting up the adapter, student recycler view adapter. Then we are initializing our student recycler view object variable using that particular specific recycler view MVVM. And then we also have the student recycler view dot set student layout manager, set student layout manager, new linear layout manager. We are setting up the adapter for the recycler view. And then we have the view model. We are creating the view model is equal to new student view model, and we are getting the application get application context that we need to pass as a parameter to this particular specific context. Okay, so we to the constructor, so we are passing it. So we are creating that particular students view model object, initializing with our in our view model variable. And now in this particular part we are initializing that particular specific view model dot get all students. It will this particular up to this particular point, it is going to give me back that live data list of the students, and on that student live data list of the students we are creating an observer. And who is the observer? That is the main activity. If there is a change inside that particular live data, it will be notified automatically to the main activity using this particular specific method, observer list, new observer list of new observer on the list of the students. Okay, so on the list of the students we have a new observer, and then we say that on changed, whenever there's a change happened in that live data list of students, it will call this particular method and pass that list of new list of the students or the updated list of the students as a parameter to this particular specific on changed method. And in this method we are saying that we have already this particular student recycler view adapter, and inside that particular adapter we have a set data method which is going to change the data part of the adapter. And let me show you quickly that view holder. This is our view holder class, which is the child of the view RecyclerView.view holder, in which we have a card view, image, ID, name, user interface, username, and the mobile, and then we have initialize. That's the part which you already know very well. Okay, I don't need to explain it further. And then this is our recycler view adapter, student recycler view adapter. It's again the sub class or the child class of the adapter, which is again help us to create those view models, view holders, not view model. We have the data part. So this is the place that we are calling it inside our main activity. This observation on data changed in the observer. When on data change, we are adapter.set data, so we are calling this particular specific method. So set data, we are passing the new list of students. We say that this data dot this is equal to data, and once we have updated the data, remember that we need to notify data sets changed. We need to notify our adapter that there is a change in the data set. So when the change happen, it will automatically update its size and create new or maybe update the information inside. So we need to notify, so accordingly it will show me the new records or the updated record instead of the old records. If we don't do that, it is not going to change or update the information inside our recycler view. Okay, so to update the information inside our user interface, that is recycler view, we have to call that notify data set change whenever we are changing our data set. So if we look at now, till now we have implemented this particular specific part. So let me quickly open that completed application, but don't worry, I will not show you the complete records. Okay, what's going on? I don't want to. What's happening? Where's my cursor? Okay, it's here. Yep, here. So let me please close that particular specific application, and let me yep. Okay, so this is our what you can say that our main activity. You can see that it's observer which is observing, and then we have add student button. So but right now we are more interested to see that everything is working. So you can see that it is reading all those 7 records, and we can click on that. It will show me the what you can say that show me the name of those students. For example, if I just want to click on Abbas Malik, so it will show me that. So we have implemented till now, everything is working. So let me go back to the application. Now what we want to add, because this is a reading part, we have not added a new student, so we need to add that particular specific part as well. What we need to do, we need to add a new activity, add student activity. Okay, we will start with the empty activity and name it add student activity. This is our user interface. Again, we are adding to the title text view. We also have these 2 buttons which we are putting the linear layout, and then we also have these uh, layout, that is like enter first name, that's these are the input fields. We also have the spinner that we have already done inside our SDLT04 to add a new student inside our room database. But of course we are not adding inside our room database, instead we are adding that into our Firebase database. So but this is the layout file that we need to create. And once you have created this one, uh, we have add student activity. Okay, so this is like add student activity. If you look at that, we have all the names of those methods, those at the edit text, because we want to access them and put all those values inside our student object. So we are initializing, we have the edit text for the first name, student name, username, student password, student mobile, gender, and then we also have created a view model object. So this is our data part. And then we have the onCreate method. In the onCreate method, we are initializing all these variables. Very simple. Initializing all those UI components, user first name, last name, username, password, mobile, gender, and then we also have that view model, and we are initializing those view variables. Second is, when we click on that add student button, we have that add student button clicked. So we have this particular specific method. In this particular part, we are testing the user is not leaving some space, leaving some input field empty. That's we are just checking. If it is empty, then we are telling the user that you need to provide that particular specific information. That's very simple. We don't need to worry much about that. On the other part, this part is where we need to, what you can say, that we are creating a new student, because user has provided all the information. There is no empty input field. We are creating the new student object. And now for the student ID, we are getting the information from the student database.stid. So it was 8 there, so it will assign 8 in the SID. And because we are post incrementing, once that particular 8 has been assigned into the student object, we are increasing that value. It means after this particular specific line, that STID value inside our student database object will become 9. It was 8, assigned it to the student object, and then later on it will become 9. Okay, and then we are getting all the values from the different fields and putting them inside our student object. And then we say that view model dot add student. Inside our view model, we have a add student method that will call the repository dot add student method, and inside the repository dot add student method, it is going to call the remote db handler dot add method, add student method, and eventually this particular specific student record will be added inside our Firebase cloud database, and it will also update the new student ID inside that particular specific student ID here. It is 8 here. Okay, so it will also be updated. And at the end, we are saying finish activity. Finish activity is again just a simple method which is present inside this activity, like this, finish activity. And then again, we also have a cancel button. On the cancel button click event, we are just saying that finish activity. And this is our app scenario. We have the main activity in which we are showing all the students reading from the database, from the cloud database, and also inserting in the local database. And this is our add database. And this is also your SDLT05. Need to create this application that I have just explained to you for this SDLT. Although is not a part of the SDLT, but we think about how we can update, changing the information in the Firebase, and how we can delete the information. Right now we haven't touched it yet, but think about it, how we can do that. And let me show you quickly this particular functionality which has been implemented. Where is my cursor? Let's go. Okay, it's gone. So I say that add. Okay, so again we need to add so which one? I don't know which. Okay, John Keats, that is what you can say, that writer or novelist which I can remember right now. So we can say that John, that is the its username, password is 12345. Okay, and then I need to give the mobile 123456. And remember, inside our room architecture, room database, local database, we have implemented that this particular mobile should be unique, but we have not implemented that kind of a stuff here, because it is not our what you can say that it is not a what you can say that it's not a relational database. So if we want to implement these kind of constraints, we have to think about it, how we can do that. And then when I click on the add student button, so you can see, look, here this ID has already become 9, and it has added that particular specific John, Keats, Mails, this one. So, and then if I come back to my activity, it will show me that particular specific last record, that is actually the John Keats. So look at that, I didn't do anything, I just add that particular record inside my Firebase database, update the STID, and it is automatically coming into my user interface. Why? Because this record has changed, the data here has changed. When that data has changed, it is automatically calling that particular specific method. Which method it is, I will show you. It is automatically going to call this particular remote DB handler read method. Remote DB handler read records. It is going to read all those records, putting that into the database using this repository, and it is also going to update the information inside our what you can say that, if I just show you quickly here, no, it is not showing up me, but anyway, so it is actually going to change your look now. The here STID value is actually have changed to 9. It was 8 before, now it is 9. So you can see that it's everything is going perfectly fine, everything has been implemented, and you need to implement all those things. I have shown you all these two codes. I have given you all the step-by-step details, so I hope you can follow those details and you can implement that particular specific SDLT and the project for me. And thank you for listening, and have a good day. Bye.